We all faces problems every day. Some are simple, like finding a file on your computer. Others are complex, like figuring out how to debug code or solve a game puzzle. What separates frustration from success is algorithmic thinking, which is a structured approach to problem solving. Hi everyone, welcome back to the channel. If you have ever felt stuck on a problem, this is the place for you. Today, we're gonna break down algorithmic thinking, one of the most powerful ways to approach any challenge. We will start with a simple example, linear search. Let's jump in. Algorithmic thinking is about breaking a problem into clear, logical steps. It's like following a recipe or using a GPS. You first define your goal, plan your steps, and follow the steps to achieve your goal. This mindset powers everything from everyday tasks to the technology we always use. Let's bring it to life with an example, finding a number in a list. Imagine you have a list of numbers 5, 8, 3, 7, and 2. Your task is to find the number 7. Sounds simple, right? But how would you approach it? Let's explore a straightforward method called linear search. Linear search is one of the simplest ways to find something in a given list. Here is how it works. Start at the first number and compare it to the number you are looking for. For example, the first number is 5. Compare with the target I'm looking for, which is 7. 7. 5 is not equal to 7. If it matches, stop that you found it. If not, move to the next. The next number is 8. 8 is equal to 7. It is not true, which is false. So that target number is not found at this step, and still the target is not found, and move to the next. The next number is 3. 3 is equal to 7. Not, because 3 is less than 7. Still the target is not found, and move to the next. The next is 7. 7 is equal to 7, which is true, and we found that our target is found at position this, so it stops finding the next number or comparing to the next number, because we stop here because we found our target that we are looking for. So this is a linear search approach. You always start from the first number in the list, compare to the target number, and if the number is equal to our target number, it stops the loop. Otherwise, it moves to the next number and compare again to the target number until it founds the target number. All right. Now let's turn this process into a Python code. Here's how you would write a function to perform a linear search. Go to your text editor. I'm using a Visual Studio Code, which is the best editor ever. And write your file name linear search.py. And you first define your function linear search, and this function going to take two parameters, the list, and the list contains list of numbers, and our target, the target number that we are going to looking for from the list of numbers. So here we are going to iterate through the list of numbers for uh, the list in the range of len LSD, which the length of the list. The loop starts from the first item in the list, and here we are going to compare that number in the list based on the position of the number. If LSD at index I is the iterator that takes us a position or index of the list. This the iterator starts from 0 up to n minus 1. So if elasticity at index I means if I is 0, that is the first element in the list. If that number is equal to the target, it returns the position of that number, which means that target number is found at position this. Okay, if this is not true, it returns the negative 1, which means the number is not found in the list. So this is a simple linear search in Python. Now we're going to test this function. Our target, for example, is 7, and the list of numbers are 3, 8, 4, 7, 2. And let's print out, the list. Linear search is linear search, and we pass the list of numbers and the target number into this function and print ls. ls. All right, now I'm going to return print out this file to see the output. Python 3 linear search. Okay, so 3 is the position where the number 7 is found. You can check out that the position always starts from 0. The first element in the list is position 0. The second element is position 1. The third element is position 2. And the fourth element is position 3. So this is the position of that number. You can see that this position. Okay, so this number is found at position 3. For example, if you are looking for 9, but 9 is not found in the list, and what will return from this program? Yeah, negative 1 means that number is not found in the list. Or you can simply return a statement. The if target is not found. Okay, you can print out a clear statement. Yeah, 9 is not found. Or you can also print a clear statement here. Target is found at index I. Okay, for example, if you change this to 8, so you can print, yeah, 8 is found at index 1. Index 0, 1 is found at index 1, and the loop terminated here because the target number is already found. So this is called a linear search algorithm. This function takes two parameters: the list, the number of list, and the target variable. So the list and the number you are searching for, it loops through the list, checking each element one by one. If it finds a match by comparing with the target number, it returns the index of that number. Otherwise, it returns that the target number is not found. All right. So in this example, the function finds 8 at position 1, but when searching for 9, it returns that it returns that 9 is not found in this list of numbers. So this is a simple approach that you are learning for how to use a linear search algorithm in Python. All right. So linear search is not just for coding, it is something you do every day, from searching for a contact list from your mobile phone to finding your name on a list. The same principles apply. Once you understand this, you are ready to explore more advanced algorithms in Python. Algorithmic thinking starts with simple ideas like linear search, but it's more than just solving a problem. It's about building the foundation for tackling bigger challenges. So start small, practice often, and you will be amazed at what you can achieve.